Just let me know in case you are able to see my presentation.
Yes, it is coming.
Yes, sir.
Thank you.
Sir.
Okay. So I have two presentations. First one is about 5G new radio key capabilities and its use cases. And the second presentation would be around certain more spectrum related aspect, although these aspects have been covered in bit and pieces here and there. But as we are starting session on 5G new radio, I'll just go through these aspects and let us try to understand, and then we'll reach to the core part of the 5G new radio. So before I start, I just want to tell you different figures of 5G which are being published and some forecast. The first thing is this particular slide is taken from a report by Qualcomm in the month of March. So as per this report, if you see, so 205 plus operators have actually launched 5G somewhere in the world, right? So this one. And there are 280 plus operators who are actually investing into 5G. That means they are trying to roll it out. These are additional numbers. The third important figure is that about 75 crore, that is 750 million smartphones are expected to be shipped in this particular year, 2022. That means in the current year, there will be around 75 crore 5G smartphone being supplied across the globe. And the next figure is very, very important. The 5G connection will reach 1 billion mark in 2023. If you compare with 4G, how much time it took to reach 1 billion. So we are reaching 2 years faster than 4G. So that clearly means that adoption of 5G, rate of adoption of 5G is much faster than 4G. The next figure is about total number of 5G smartphone which will be shipped during 2020 to 2025, 6 years. Every year. And there are more than 1275 types of different design of phone, dongles and other 5G devices, which are either developed, launched or under development. So this clearly shows that there is a fast, accelerated rate of 5G deployment and adoption globally. So with this figure, let us start our presentation. So before I talk about different capability, let me tell you that how requirement or vision of a particular mobile technology is evolved. So ITU plays a very, very critical role, particularly the radio communication sector of ITU. ITU-R, we call it ITU-R, radio communications sector of ITU. They create a vision document for a particular technology. They started from 3G, right? So they came out with the vision for 3G, then 4G, and finally in year 2015. This is the document ITU-R M2083, which I have shared with all of you, which gives the vision of IMT 2020. So basically the ITU name for 5G is IMT 2020. So they had given a vision what should be the framework or overall objective of IMT 2020, right? And that vision came in 2015 itself. So we all know that there is a 10-year cycle of any mobile technology to come into the market. So every 10 years we are changing from 1G to 2G, 2G to 3G, 4G to 5G, right? And even 6G will take almost 10 years the way it is going as of now, right? So once these vision documents are created, ITU also create minimum requirement, minimum technical requirement for that particular technology, that is 5G new radio in our case. And this document M2410, just see this, was released in November 2017. So this gives the specific technical performance requirement of 5G new radio. So my presentation, first part of presentations are taken from these two documents. So you can read these documents if you want to go into detail. And I will be just going through the crux of these two documents. So these two documents talk about three key usage scenario of 5G, which is eMBB, URLLC, and MMTC. So from here itself, I would be requesting that some of you can either in chat box or you can open the mic. Can you tell me the full form starting from eMBB?
Sir, enhanced mobile
Broadband, you are right.
Massive
mobile machine.
Go ahead, please.
massive machine telephone communications.
Sir, massive machine type communication and ultra reliable low latency communication.
Very right. So you guys are right. So enhanced mobile broadband, massive machine type communication, and ultra reliable low latency communications. So these are generic scenarios. So any use case would be using some property of eMBB, some property of MMTC, and some property of URLLC. For example, if I talk about a autonomous car, self-driving car, that means latency and reliability is important. So the major aspect of URLLC it will be using, but your car will also have cameras, audio, video systems. So eMBB is also important to some extent, and your car will also be having lot many sensor installed in different part of your car. So MMTC would also important. So major requirement is URLLC and sub part from eMBB and MMTC. Similarly, for any use case, there will be a combination of URLLC, eMBB, and MMTC will be talking about. So let us talk about now eMBB, enhanced mobile broadband, and what are the key capabilities of eMBB which is required to make it happen, right? The first parameter which I'll be talking about eMBB is the peak data rate. I think I have moved one slide. Okay, it's coming as a peak spectral efficiency. I think I have missed one slide, but let me just tell you about the peak data rate. So I'll just write here peak data rate. So can someone of you guess that what is the vision of ITU in related to peak data rate of 5G? Can someone tell me either in the chat box or you can open your mic?
So 20 Gbps.
So yes, you are right, 20 Gbps. Somebody is saying 100 Gbps, somebody 1 Gbps. Correct answer is 20 Gbps. And that too in downlink, right? In uplink, what should be the peak data rate? What is the vision of ITU in respect of peak data rate for uplink? So Mr. Siu has answered right. Himanshu has also answered right. It is 10 Gbps, right? 10 Gbps. And can somebody tell me when I say peak data rate, what does it mean? इसका मीनिंग क्या है, कोई बता सकता है?
कि सर जब हम डाउनलोड करेंगे या अपलोड कर रहे हैं तो उस टाइम हाईएस्ट कितना उसका स्पीड मैक्सिमम पॉसिबल है, फिजिबल कितना होगा?
ओके राइट, एनी अदर आंसर? कोई और इसका आंसर देना चाहे?
So it means a dedicated user is either uploading or downloading the data from that particular link.
Right. Any other more precise answer somebody want to give?
और सर विदाउट कैरियर सेग्रीगेशन जो आता है सिंपल एट ए टाइम कितना ले पाएगा, मतलब अपलोड हो पाएगा?
Okay. So if you read the definition in the 2410 document which I have shared, they say that in an ideal condition, if the entire resources is allocated to the one user, single user, right? And all the parallel transmission which is possible is also given to that user. In that case, whatever peak data rate is able to achieve is called peak data rate. You can open the document and read the definition. So that is your peak data rate, 20 Gbps and 10 Gbps. Let me erase this and move forward. Okay, now let us talk about peak spectral efficiency. So here also I would be asking that what is peak spectral efficiency or spectral efficiency? Someone from you should answer that. What is, when we say spectral efficiency, what is meaning of it? Anyone?
Yes, sir.
30 bps.
Hello.
Sir,
Means
bits
that
per second
frequency
per hertz.
spectrum. Hello.
Sir, number of bits per second per hertz.
Hello.
Bits per hertz. Okay, good answer. Anybody else want to add?
Sir. Means that frequency spectrum is maximum utilized. Means no frequency band or channel is wasted. Total frequency band can be maximum utilized. That frequency spectrum, sir.
So basically the definition of peak spectral efficiency is that in 1 hertz of the frequency, 1 hertz, how much data rate you can achieve, right? That is bit per second per hertz. Bit per second per hertz. So can you guess what is the spectral efficiency of 5G? It is 30 bit per second per hertz in downlink and 15 bit per second per hertz in uplink. Now I have a question. Many of you are from DOT and BSNL. So suppose I have 100 megahertz of spectrum and my theoretical spectral efficiency is 30 bit per second per hertz. So how much peak data rate I'll be able to achieve?
3000.
3000 watt. What is the unit you are talking about?
3000 megabits per second.
Very right. 3000 megabit per second is actually 3 Gbps. Am I right?
Yes.
So if I allocate 100 megahertz of spectrum, the maximum data rate one operator can achieve theoretically is 3 Gbps. Now in the last slide we learned that the 5G will have peak data rate of 20 Gbps. So can somebody tell me that to achieve 20 Gbps, how much spectrum I need to actually allocate to the operator? My requirement is 20 Gbps and spectral efficiency is 30 bit per hertz per second. So how much spectrum do I need?
20 mega.
20 Gbps divided by 30 bit per second. So how much bandwidth I require to achieve this 20 Gbps?
Sir, 1.5 Gbps.
ये कहाँ 20/30 करिए, ये Gbps है और ये Bps है.
700.
एग्जैक्ट बताइए. 700 एग्जैक्ट आंसर नहीं है.
667 megahertz.
6.6.
666
6.6.
megahertz.
666 megahertz. Yes.
Very right, very right. So minimum channel bandwidth or spectrum which is to be allocated to an operator is about 600, 700 megahertz theoretically. Actual requirement would be slightly more because this peak spectral efficiency and all is theoretical figures. So you need to allocate them more spectrum. So those from DOT and handling policy should understand that we need to allocate a big chunk of spectrum from different band to our operator so that they can actually deploy real 5G into their network. Let me erase this and proceed further. And if you compare this with 4G, it is 3 times better. 3 times better. That means what was the spectral efficiency in 4G LTE? अगर ये 3 times better है तो कितना होना चाहिए था?
3 bps sir.
10.
10,
30 है ना?
10
bit per second per hertz. Am I right? So can somebody tell me that today our operators who are offering 4G services, how much bandwidth do they have? Any are from BSNL? They just tell us that BSNL in some circle have LTE. How much bandwidth? I mean, so Ritu is saying 10. Okay, 10 is answer for the other question. My question is that any of the operator, how much bandwidth today they have for 4G?
At around 50 megahertz in different bands.
How much?
Sir, 50 megahertz in different bands. Like
okay, let us assume they have 50 megahertz of bandwidth. With 50 megahertz bandwidth and 10 bit per second, how much data rate they'll be able to achieve? Theoretically, at least. Just multiply, you will get it.
500 Mbps.
500 Mbps. But practically, they have not deployed entire 50 megahertz because they have 2G, 3G network also. They have deployed around say 20 megahertz, right? So with 20 megahertz, how much they'll be able to achieve? 200 Mbps.
200, yes.
Right? Practically, when you do speed test in your mobile, how much do you get? How much maximum you have got till now? Anyone? आपको कितना मिलता है स्पीड? मुझे तो 30-40 Mbps मिलता है, आप बताएं.
30 mbps sir maximum.
30, okay. मुझे 40 तक भी मिला है. Anyway, so all because those are peak speed and we are talking about average speed or user experience speed. I'll talk about that. Now the next parameter is user experience data rate. So let me first explain you what is user experience data rate and then talk about that. So basically, if you have your BTS here or the radio here, so you'll be covering certain area. So if you go to edge of your network, your speed decreases. Your speed near the BTS is highest, then it goes decreasing. The definition of user experience data rate is that if you go to the 90% point, that means coverage se thoda kam. So in this 90% point, whatever speed you are able to achieve is called user experience data rate. So that clearly means the minimum speed which you should expect is the user experience data rate. For 5G, it is 100 Mbps. For 5G, it is 100 Mbps. Is it clear to all of you? Yes, no in chat box. Please write yes, no, or whatever in chat box. Yeah, okay, thank you. And do you know that this particular rate, user experience data rate, is 10 times higher than LTE? LTE, it is 10 Mbps. User experience data rate, which I explained, is 10 Mbps. That is LTE means 4G. So it is 10 times better than 4G. Now let's go to the next parameter called mobility. So all of us know that even in our country now, the high-speed trains are being deployed. So that can go up to speed of 400, 500 kilometer per hour. As of now, our LTE supports only up to 380 kilometer per hour. That means if your speed of your train is more than that, your mobile will not work. So 5G supports up to 500 kilometer per hour, and this was taken care thinking about bullet trains, right? In our country also it is being rolled out. So even in a bullet train, your mobile will keep working. 4G may not work, but 5G will work. Now, next usage scenario, that is URLLC, ultra reliable low latency communication. So what are the key performance requirement for URLLC, right? I think somebody has raised hand. You can straight away open mic and ask your question, Praveen.
Yes, sir. So my question is that whatever is the user experience data rate which has been governed by the ITU or with the standard, in which band? Is it in the FR1 or is it in FR2 and which technology? Is it the TDD or is it the FDD?
Your question I could not understand. If you can, your mic is also, I mean, your sound is not coming proper. Can you
Sir, are you getting my?
a bit
Are you
loudly
getting?
near to the mic?
Are you getting me now?
थोड़ा आवाज कम है, थोड़ा तेज बोलिए.
सर आ रही है आपको आवाज? Are you getting me, sir?
अभी ठीक है, ठीक है.
Sir, my question is that what is the user experience data rate, which is the 100 Mbps, and my question is that whether it is being due to the TDD deployment or due to the FDD deployment, and in which particularly 5G band the speed is being
So
user experience.
basically this is a vision or requirement given by ITU. So that means in any condition, these are the minimum. User experience data rate means onto the edge of a network. This is the minimum data rate I should get. Then only my network would be called as a 5G network or IMT 2020, irrespective of what technology I am using behind, whether FDD, TDD, FR1, FR2, right? Which kind of modulation. So irrespective of that, those requirements are the minimum requirement, right? Okay, so let us talk about URLLC now. So what are the different key performance requirement of URLLC? Let us first talk about latency. Can some of you tell me that what do we mean by latency?
Delay in the packets.
So time gap.
Okay. Delay or time taken to reach a packet. So basically when I send something to you, how much time it takes to reach you, right? So that is called latency. So kind of an end-to-end latency, including starting from a device to base station to the core, and finally where it is getting delivered to the next device or to internet service. So that is latency. But before I talk about this, do you know what is latency of your eyes? When I throw something to you, आपका आंख blink करता है. So how much time it takes to blink your eyes, right? वो response time कितना है?
It in the milliseconds.
Millisecond.
0.1 milliseconds.
Anybody else want to answer? You can also Google.
Sir, 160 to 180 millisecond.
160 to 180 milliseconds.
1/10 of a second.
Okay, so it is between 200 to 300 millisecond. So average is 250 millisecond, we can say. So our latency, our eyes latency is between 200 to 300 millisecond. And have you checked when you do a speed test on your mobile, वहां पे एक आता है पिंक टाइम आता है, वही लेटेंसी है. आपको कितना आता है? हैव यू सीन? कैन somebody just check it and tell me that what is the latency you are getting? Just do a speed test quickly and tell me.
Sir, it's a 16 to 20 means 15 to 20 milliseconds. We are getting it.
Achha, in your case, you are getting 15-16 millisecond.
Yes.
Okay, so let me write. So basically, somebody is getting 16 millisecond. Manoj ji is saying 20 millisecond, and so on. So that is the latency we are actually getting in the network. 5G has envisioned a latency of 1 millisecond. So seeing this, just tell me, when I did just now a speed test, I got 185 millisecond on Airtel network. So it depends from place to place also. So 1 millisecond. Now, can you guess that what kind of application we are talking about when we are talking about URLLC? Any real world example can you tell me? कोई application बताइए.
Real time applications.
Car, sir.
Okay, autonomous car. Any more?
Remote surgery, sir.
Remote surgery, very right. One is the remote surgery. Other is the autonomous car or self-driving car. So now tell me that as a human eye, I have a latency of 250 millisecond, whereas a machine can have a latency of 1 millisecond. So when a car is being driven by a human and a car is being driven by a machine, collision, chances of collision is less in whether by, driven by human or by machine.
Less by driven by machine, sir.
Yes, all because the latency there is less compared to human eye. जब तक आप सोचेंगे तब machine can take decision fast. बाकी है. Latency is the not only aspect. There are many other aspects because you have to process the data also before you take the decision. So role of AI ML is also important. Just as a rude example, I told you. Let me erase the. Yeah.
Sir,
Please go ahead.
this latency is for the user plane or control plane latency?
Very good question. So this latency I'm talking about, if you read the document in the ITU, they are talking about two kind of latency. One is the user plane latency and the second is the control plane latency. So user plane, this 1 millisecond is an user plane latency, and particularly for URLLC applications. If you talk about eMBB, they have talked about 4 millisecond.
Okay.
That is given in the document. And for control plane latency, it is 20 millisecond. Since you have asked these questions, I had not put it all because I do not wanted to confuse you. Control plane latency is 20 millisecond. So let me now ask, what is control plane latency? Can somebody tell me?
Sir, delay in signaling with signaling information, and user plane is delay in the actual voice or actual data we need to transfer.
So control plane, I would request someone to read the document which I have shared and answer that. So control plane latency is kind of, suppose your mobile is idle and you want to now use a service or transfer some data. So from that time till you are actually started sending the data. So in between, lot of signaling will happen, lot of processing will happen. So that time is called control plane latency. It's not only one signaling message which has to happen before I actually start sending the data. So from idle time to active time, whatever time it takes from idle state to active state is called control plane latency. It is only one time when you start the service. Once you have started the service, your user plane latency will be important, not the control plane, right? Is it okay? Yes, no in the chat box, please.
Yes, sir.
I think Ramesh has raised the hand. Please go ahead and ask your question. Ramesh BR. Okay, if there's no question, then let me go ahead.
Sir, sorry.
Yeah, please go ahead.
That was by mistake.
No problem. Now let us talk about reliability. So there are two kinds of reliability. One in terms of how much error, whatever data I am sending, there may be certain error coming due to the channel or due to the other aspect. And other is the availability of the network itself. So let me ask some of you that in terms of reliability, in terms of bitrate error, if I say that my bitrate error is 10 to the power minus 6. So just translate this into percentage. Reliability percentage, how much it will come? Can somebody calculate and tell me? If I say that bit error rate is 10 to the power minus 6 for URLLC applications, so how many 9 I am talking about? 99.9999% which you 5969 we talk about. So how many 9 I am talking about? Can somebody tell me? So basically when I'm saying 10 to the power minus 6, what I'm saying that out of 10 lakh or 1 million bits, 1 bit of error can be tolerated. 1 bit of error can be tolerated. So in 1 lakh bit, how many correct bit I am getting? 1 lakh minus 1. So in 100 bit, how much correct bit I'll get? So if you calculate this, you'll get the percentage. So Karan Goyal has answered rightly in the chat box, that is 99.9999%, 6 nines. जो 5969 बोलते हैं वो यहाँ से आता है. So 6 nines kind of reliability we have in 5G, particularly for URLLC application. And that is the vision which ITU has given. Actual machines may have some different, but that is the vision which ITU had given. So it has to be very, very reliable, ultra reliable in terms of availability and also in terms of error rate. Okay. And they are talking about mobility interruption at 0 millisecond. When you move from one base station area to other base station area, we call it G node B. There has to be no interruption. To make before break kind of environment has to be there, as we have URLLC kind of applications running onto the network. So here comes your control plane latency, you can see here. Okay, now let us move to massive machine type communications, MMTC. So can somebody tell me that what should be the key performance parameter for MMTC? So MMTC is nothing but sensors, different kind of IoT sensors, which will be installed in every object, machine, even in our household, every fridge, every AC, every bulb will have some kind of sensor connected to 5G network. In agriculture field, you'll have a lot of sensors for soil monitoring, your equipment monitoring, so on. So what kind of performance requirement are we expecting in case of MMTC from 5G? Please guess, write in chat box or open your mic. One is capacity, other is positioning. So Salini has said capacity, Ritu has said positioning. Any more answer? Coverage area, very right.
The network energy efficiency.
Plug and play type, very right, Karan.
Efficiency of data.
Energy
Efficiency of data.
Okay, very nice. Sudhanshu Kumar Misra says high connection density, very nice. Energy, do not need to charge. lifetime battery.
Efficient. Data
Very right.
efficiency.
So, yes, you guys have got it. So the first key thing is the connection density. So as per vision, it is 10 lakh devices per square kilometer. In a square kilometer, if there are a lot of sensors installed here and there in object machine, so it will support 10 lakh devices per square kilometer. Now the second key part is your energy efficiency. Why energy efficiency is important? Can somebody tell me, open your mic and speak, that why energy efficiency is a very, very important for IoT or MMTC kind of application?
So that device sensor do not need to charge for the entire life cycle.
Very right. And why that is the requirement? Charging is not available. Yes. These sensors you may be required to install. Suppose you want to monitor disasters, right? Natural disasters. So you have to install these sensors in a very, very remote hilly terrain or remote terrain. So there you will not have any option to charge the power of the battery which your IoT sensor is having. So unless you have a very, very big life, 10 years, 10 years, 15 years kind of a life of your sensor, it is useless. Similarly, a lot of sensors would be there in the warehouses deep inside into basement and all. So it is very tough to charge or replace the batteries, right? So our network as well as our devices supporting IoT has to be very, very energy efficient. Otherwise, it will not make it happen, right? So basically, what we say, it is 100 times more energy efficient compared to 4G. 100 times more energy efficiency in 5G compared to 4G. And there has been a lot of technological changes in the architecture, in the design. Every aspect of design has taken care about energy efficiency. Going forward, when we move into more detail into our subsequent session, one by one that will come and I'll be pointing it out to you that how particular aspect is saving the energy.
Ashokji, I would like to add to this part of energy efficiency thing.
Yeah, sir, please go ahead.
Yeah, as you have rightly mentioned that these remote devices like operating through IoT and other means, of course, they need to be charged after a very, very long time, maybe 2 years, 3 years. That is one part. What we also understand by in this 5G, that the energy, it has to be much more greener. I mean, as compared to the previous regimes of our mobile systems like 4G and 3G and others. And in addition to these last devices, even our equipment, including the core network and other equipment, they also have to be much more energy efficient because we can't afford to waste more energy now. And the BTSs are so much near. I mean, the density of the different base stations to say, which we can loosely we can call it, they are so much near that if we don't save on energy, we will not survive actually. So as you said, why is it most important? I think that part seems to be the most important because we are growing like anything. I mean, it is a huge expansion and it has to be backed up by a huge energy saving for our sustenance.
So thank you, Jha sir, for adding this particular aspect. So let us move forward. The connection density and energy efficiency, and third important aspect is the coverage, which some of you have pointed it out, because since it has to be very, very remote area and far away places, so your network coverage has to reach. So that is of course as equal or important as connection density and energy efficiency. Let us just quickly compare the capability of 5G and capability of 4G. This particular spider diagram also I have taken from the vision document which I have shared. I'll just explain you very quickly. Starting from the peak data rate. So inside this light green color which you see, where we have written IMT advanced is nothing but your 4G. 4G in terms of ITU is IMT advanced, and the dark color is for 5G, which is IMT 2020. So the peak data rate for 4G was 1 Gbps, for 5G it is 20 Gbps, so 20 times increase. Area traffic capacity, that is in a particular square meter, how much data can be pumped from 0.1 megabit per second to a 10 megabit per second. Energy efficiency from 1x to 100x, 100 times better. User experience data rate from 10 Mbps to 100 Mbps. Spectral efficiency from 1x to 3x. Mobility from 350 to 500 km per hour. Latency from 10 millisecond to 1 millisecond. And connection density from 1 lakh to 10 lakh. So just see the increase is 20 times, 100 times, and so on, 3 times on different parameter, different, right? So that is the comparison with 4G. Now this diagram is also taken from a vision document, which I'm talking about and have shared. This triangle they are talking about, that you have eMBB here on top, you have URLLC here, you have MMTC here. So how combination of these three would constitute various type of services, right? For example, if you talk about 3D video, USD, so eMBB feature will be very, very high. Latency, URLLC and MMTC feature would be less, and so on. So it's a smart home, voice services. So on this triangle, you see different services requiring different aspect of the three scenario. Some pictorial use cases shown. For example, eMBB, you may have USD video streaming, virtual reality, AR, VR, stadium-like environment, and so on. So this you can go through. Your AR, VR kind of applications. MMTC can have applications in smart cities, smart home, agriculture, wearable, fitness. URLLC can be autonomous cars, robotics, aviation, industrial automation. These are just a pictorial kind of representation, self-driving car. The public safety, which is one of the important aspects government has to take care, or 5G will really come handy because of the capability of 5G, your connected sensors can help reduce loss of life, loss of property. 5G drones can actually support emergency situation, remote consulting, V2X and all. These are all aspects of public safety. Similarly for industry 4.0 like digital replica, another aspect will actually come very handy. And then for agriculture, a lot of use cases. In India, we will have a session on 5G use cases from industry leaders going forward in this course. So I'm not going much into detail. I'm just showing you that for experience, AR, VR, XR, all these are use cases of 5G utilizing the three properties or three usage scenario. So with this, the first part of my session is over. I'll give you 5 minutes break, or maybe let us have 5 minutes discussion or question answer, and then perhaps we can break for 5 minutes and join again. So any discussion point or question which you may like to do with me? Kindly open your mic, video, and just have a discussion about whatever we have learned. And then we'll start our next session, next 1 hour session.
Sir, good afternoon, sir.
Namaskar.
Sir, how that latency is reduced to 1 millisecond, sir, in 5G?
So how we can reduce latency to 1 millisecond? What are the different ways by which we can achieve 1 millisecond latency? So I'll tell you one or two aspects of it. The one aspect is that when you talk about latency, you talk about two aspects. A set of data. Say, if you talk about URLLC, ultra reliable low latency communication, in such type of communications, So high data rate is not required. Latency is very important. Reliability is very important. So maybe they would require maybe few kbps, 400 kbps, 200 kbps in a millisecond. Within a 1 millisecond, there may be a requirement to pass on 100 kbps only, kilobytes only in 1 millisecond, right? Now you look at a scenario where a base station is covering 4, 5, 6 kilometer, right? So in case your base station is covering 5, 6 kilometer, so your, signal has to travel 6 kilometer and come back. So here the latency is because of the coverage. You have a large coverage, and because of that, the latency is counting for. You may not be able to achieve 1 millisecond latency if your coverage area is very high, because that's a natural. No one can actually reduce this latency because of the distance by to which we are covering. For example, if you talk on a satellite phone, there is a actually you can guess the delay. वो अभी हेलो बोलने के बाद थोड़ी देर बाद हेलो पहुंचता है. So you can know in the TV also, you know, when the broadcasters are doing live broadcasting, after speaking, after asking question, they have to wait for certain time for the response to come. Because of that latency, you cannot reduce that. So that means you have to reduce your coverage. The first parameter is the coverage area has to reduce, and so you have to reduce your coverage. You have to have a small cell. Your applications which require latency need to have n number of base station nearby serving them, so that the coverage area is less, so latency is also less. Second important parameter is that when you are covering a larger area, so you also need some time guard, right? Time guard. So what is that time guard? That is kind of an inter-symbol interference. When a signal is received from multi-path, there'll be overlap and there'll be an inter-symbol interference. First symbol will interfere with this, previous signal. That is also, and to sort out that, you have a guard band. There are certain guard band which actually impact even the latency, because that much time period is wasted. So that is also add to your latency. The third parameter is that suppose I'm a user, I want to just send a data or use a service, but network. So don't play with the team platform, please. So the next answer is that how scheduling is happening, how often network does scheduling. If the scheduling is every 1 millisecond, which is there in the 4G every 1 millisecond scheduling. So even you want to send the data, network will give you resource in the next millisecond. So the scheduling is important. In 5G, you have a flexible scheduling, 1 millisecond, half millisecond, 1/4 millisecond, 1/8 millisecond, and so on. So scheduling is important. And the fifth aspect is, can I puncture a 1 millisecond time period or that particular scheduling and schedule a priority data then and there? So all these aspects are contributing to latency, which is taken care in 5G. Have I answered your question?
Yes, sir. Thank you, sir. That means that cell radius is reduced, cell size is reduced. That's why that latency is reduced.
Not only cell size, the scheduling period, cell size, or that is, we call it cyclic prefix. There are many aspects which is taken care to reduce the latency, which we will cover in the upcoming sessions.
Thank you, sir.
Sir,
now in
yeah, please go ahead.
Okay, sir, namaskar, sir. Sir, my query is regarding the transport part, transmission part. We are expecting 20 Gbps in uplink and 10 Gbps in the downlink mode. And based on our old experience of 3G, when we have planned for 384 kbps or 2 Mbps, we have upgraded the BTSs, but 3G BTSs they required minimum 4 PCM, and we were not in position to provide 4 PCM. Rather, after that time, it required IP. So I mean, such a huge bandwidth, are we also planning to upgrade our transmission systems, and knowing the fact that in India, as of now, only 35 to 40% BTSs are on fiber?
It's a very right question, and uh, uh, I mean the answer to it is that of course we require more and more fiber and near to the base station, so that we have a fiber backhaul and we don't have an issue of having less backhaul connectivity. Otherwise, we may not be able to achieve what 5G vision is. That is number one. So to achieve this, one is the fiber. Second thing, we are talking about E-band radio. So when I say E-band, I'm talking about 70 gigahertz, 80 gigahertz kind of spectrum band where you can achieve fiber-like radio communication. So wherever you are not able to reach fiber on a short-term basis, you can install those E-band radio. So there are two aspects of it. One, that Government of India or DOT has to allocate E-band to operators to use as a backhaul for deploying 5G or any other technology. That's a policy decision which government has to take. And the fiber, those operators have to actually bring in. And there are some other technology which is inbuilt in 5G, which I'll talk about while I'll take the session. That is called IAB, Integrated Access Backhaul, which I'll be talking about later. Any more query, question, or anything? Any damn question? Yeah, please go ahead.
Yes, sir. Sir, TCS is going to provide 4G equipments to BSNL, and in that 4G, TCS told that it can be converted to 5G. And what is the difference between standalone and non-standalone, please, sir?
Okay, so what is SA and what is NSA? SA is standalone, NSA is non-standalone. So when 5G initially was kind of specification by 3GPP came out to release 15, so at that point of time, across the world, the operators are having 4G network. So how some benefit of 5G can be taken utilizing the 4G network itself. So what the specification said that you can deploy 5G base station, we call it G Node B, right, and connect to the 4G core with very minor kind of modification into that. So when you connect a 5G BTS into 4G network, where 4G core will handle that BTS, we call it NSA, non-standalone, right? So here your 5G BTS is kind of a slave and your 4G BTS is master. But on the radio part, if you have a 5G device, it will latch you to the 5G BTS which you have connected to 4G network, and 5G kind of speed, eMBB kind of scenario you can achieve, not URLLC or not MMTC, but at least the eMBB part you can achieve. So across the globe, operators started deploying 5G base station into their 4G network, that is called NSA. When you have 5G core and 5G radio, both, then we'll call it SA or standalone. Am I able to answer your question?
Yes, sir. Thank you, sir. But when 5G, these nodes are used for in 4G, then frequency spectrum it will be same, sir, for 4G and 5G.
It's a very right
frequency
question.
Spectrum.
Very right question. So there are two ways. One is that whatever spectrum you have, suppose you have 50 megahertz or 60 megahertz, you can physically divide some spectrum for 4G, some spectrum for 5G. That is one way of doing it, right? You can divide that. The second option is that in 5G, there is a concept of dynamic spectrum sharing. There is a way that the same spectrum can be utilized by 4G and 5G on a dynamic basis. Every 1 millisecond, system will decide that whether the 4G traffic is more, 5G traffic is less. Based on that, resources will be allocated to 5G or 4G devices in a 1 second basis. Every second that decision will be taken. So that is called dynamic spectrum sharing. we have 2 hour session on this going forward. So there are two ways. Khagesh, please go ahead.
Namaskar,
Khagesh,
sir.
yeah, Namaskar, Khagesh, please go ahead.
Sir, just I'm asking that whether 5G can be used for the backhaul of 4G because bandwidth is very high in there, availability is there.
Okay, so if you go to release 16 of 5G, they have talked about IAB, integrated access and backhaul. In that, the next BTS is taking backhaul from the previous BTS. But it doesn't say that it will create a backhaul for 4G. So answer today is no for 4G, but yes for 5G. Jha sir has also raised hand. Sir, please go ahead.
Yeah, I was listening to the very interesting conversation. You are rightly answering, but I also want to share about that latency part. So basically, it's not practical now, but there is no harm in dreaming. Dreaming big is always allowed. And in that, I will tell you that in optical fiber also, such inventions or research is in progress, through which they are again trying to reduce the latency. So I will just take 1 minute to say that. So what they are conceiving is that hollow core fiber that is already under research. It is already research is being done on that, and it may be used for transoceanic these submarine cables in which there is a very huge length is involved. So once it is hollow core, then in that air is there in the core, and the speed of light will be more in the air than it is in the glass. And that way also it is if it is implemented, then it will be really much more faster than what we are getting the speed on this optical fiber right now. Just I wanted to add it to your discussion. Thank you.
Thank you. So now let us have 5 minutes break and we'll join at about 4 now. So everyone can take a small break and join back in 5 minutes. So shall we start? Say yes, no. Are you ready?
Yes, sir.
Yes, sir.
Yes.
Great. Okay. So there are big topics, 7 topics, which I will try to cover. The first thing I'll talk about, so the overall topic is spectrum related aspect. All the aspect related to spectrum I'll be talking about for 5G new radio. 5G radio, we call it new radio, NR. So what are the different frequency band which is supported by 5G? Then I'll talk about channel bandwidth supported in 5G new radio. And what kind of waveform, what kind of modulation is used? Then what is the concept of numerologies in 5G? There's a concept of subcarrier spacing, resource block. Then we will talk about what are different relation between numerology, bandwidth, frequency band, cell size, and so on. And then little bit about carrier aggregation and bandwidth part. So these are the 7 topics which I will try to cover in next 1 hour. And I mean, we will be interacting kind of with each other. I'll be asking certain questions. The first topic which I'll try to cover is the frequency band supported. So before I actually start, let me ask many of you in BSNL. So if you talk about 2G, so what was the band supported in 2G? Which band we used in 2G?
900 and 1800.
900 megahertz, 1800 megahertz, right? And 3G. So, and in this also we had how much bandwidth? Do you recall?
6.2 and 3.8.
6.2 megahertz, right? Okay. And 3G, how much? Which?
2100.
2100 megahertz.
5 megahertz.
And 4G? Anyone? BSNL?
2300 megahertz.
2300, sir.
Megahertz, right? So these were different bands which we were already using for 2G, 3G, and 4G. And almost the entire availability of the bands are already consumed, right? So what will happen to 5G? We cannot straight away use this frequency band unless we reform close 2G, 3G, 4G. These frequencies at least cannot be used. Okay, so these frequencies which are less than 1 gigahertz, which we talked about 900 megahertz and other bands like 700 megahertz band, 600 megahertz band, 400 megahertz band, those are less than 1 gigahertz and we call it low band. And in these bands, we already have 2G, 3G, and 4G. And 5G will also, may I request that some of you have kind of opened your mic or kindly mute yourself unless you are looking to talk to. Okay, I'm just muting all of you.
Kindly unmute, sir.
Okay.
So please, you have go out muted. So please unmute.
So can you hear me now?
Yes, sir.
Okay. What I would request that some of you are also having opened your mic, so kindly mute yourself unless you want to talk to. So the low band, which is less than 1 gigahertz, 2G, 3G and 4G are also deployed onto these frequency, and 5G also supports that. But since availability of this spectrum would not be there because we already have 2G, 3G and 4G, so it's very difficult to use these frequencies for 5G unless we are able to refarm it, close the 2G, 3G and 4G and use those bands for 5G. But 5G supports those bands, or a new lower band like 700 megahertz in India, or other bands are auctioned and those are purchased by the operators. Now we have mid band, lower side of mid band, where we talked about 1800 megahertz band, 2100, 2300 megahertz band. So many of you told that on these bands, even 3G and 4G services are launched. In some case, even 1800 we use for 2G. So primarily it is 3G and 4G. And 5G will also support it, right? So 5G supports even the lower side of mid-band. And some of the mid-band frequency, which is there from 3.5 gigahertz to 7.125 gigahertz, those are vacant today. Those are vacant today, so those bands can be supported by 5G. Some of it are supported by 4G, but 5G will definitely support. If you talk about band N78, which is 3.5 gigahertz, that is called kind of a gold band for 5G because this band is mostly not used by any operator across the globe. So this is becoming one of the favorite band for 5G while being deployed world across, because of the availability and also the good property it is in between lower band and millimeter wave. And of course the high band, which is from 24 gigahertz to 52 gigahertz as defined by 3GPP. So there we can launch 5G services on those millimeter wave. So what we see here is that the earlier technology were using certain bands, either low band or mid band or low and mid band, whereas 5G supports low band, mid band, and also the higher band in millimeter wave. So that is frequency band support. So let me tell you that how these frequencies are. Lalit had asked this question day before yesterday, that how these frequencies are decided, which frequencies or which band to be used for which technology. So first of all, identification or earmarking of frequency band for mobile is done by ITU, rather ITU-R sector, right? And since countries are member countries, so accordingly countries also allocate the designated bands to their telecom service provider. Although they are not bound by ITU regulations, but generally they allocate. If they will not allocate the same plan which is decided by ITU radio regulation, then what problem will come that when you go for roaming, your mobile may not work. You will not get economy of scale. Your devices or the BTSs in your market may be costlier if you're not following ITU radio regulations. So it is important for development of ecosystem, economy of scale, and also you have interoperability across the globe. So once those frequencies are earmarked by ITU, 3GPP is a kind of a standard making organization for mobile as of today. Specifies particular band for a particular technology. For example, for 4G, they had decided that these are the band which will be supported. And for 5G also, they have given certain band. Now let us talk about what are the additional frequency band earmarked by ITU-R. Every World Radio conference, which is held every 4 years, where all the member country, there are 180 plus member country of ITU, they participate and they decide which are different frequencies which will be used for mobile communication and also for satellite. So the last WRC was held in October to November 19, wherein 5G bands were identified, right? So these were the bands. You see that these bands are in millimeter wave, 24 gigahertz, 37 gigahertz, 45 gigahertz, right? 47 gigahertz and 66 gigahertz. If you calculate total of it, total bandwidth, it is 17.25 gigahertz. Additional bandwidth in different bands were earmarked by earmark. Take my word, it is earmarking only, right? And do you know that how much spectrum was earlier allocated for mobile communication? It was just 1.9 gigahertz. It was just 1.9 gigahertz. This figure, right? This was the only allocation. So how many times additional spectrum was earmarked during WRC 19? Can you calculate? Is it 8 times? So just see that since 5G would require, as we had calculated in the first session, 700 megahertz, 800 megahertz by each operator in every LSA. So that's why earmarking of millimeter wave was done in the WRC so that sufficient spectrum is available across the globe for 5G. Just see this. What I'm trying to show here is that what are the additional bands in addition to whatever band are already available for 2G, 3G and 4G were allocated for 5G by 3GPP. So there are two ranges, we call it frequency range 1, which is from 410 megahertz to 7.125 gigahertz. The other is the FR2 frequency range 2, which is from 24 gigahertz to 52 gigahertz. So within these range, certain number of bands are decided by 3GPP for 5G during release 15 and 16. This covers up to release 16. Release 17, some additional bands are also earmarked. So just see, this is N78. That is a nomenclature which is from 3.3 to 3.8 gigahertz. N77 is from 4.2 gigahertz. N79 is 4.4 to 5 gigahertz, right? So these three additional bands in FR1 and these four additional bands in FR2 is kind of specified by 3GPP in their standard release 15 and 16. So that means 5G will operate not only on the bands where your 2G, 3G, 4G operate, but also on these three bands. So this is your mid band, the new frequency band, because it was earlier not used by any mobile communications. These are also millimeter wave in FR2 range. So let me ask you why we call it millimeter wave. Can somebody answer?
Wavelength in the range of millimeter.
Right, sir. Very right, sir. The wavelength of these frequencies, if you just inverse these frequency band, you'll get the wavelength which will be there in the millimeter size. So this is complete list. I'll try to spend some time here on this particular chart. I hope it is visible to all of you. Those who are using mobile may not be able to see. Those who are using desktop laptop will be able to see it definitely. Just see the nomenclature. So the nomenclature is N1 and N is for kind of new radio, N1, N2, N3, N5, N7. These are different frequency band which were already there for 2G, 3G. I mean for 4G the name was B1, B2, B3 and same range was there. And what you see that here these bands are from up to this place, these are FDD band. What is FDD? Can somebody tell me?
Frequency division multiplexing.
Division
Duplexing. Duplexing.
Different from downlink frequency.
Yeah.
Uplink
So you have
range is different from downlink frequency range.
very
Some
right, very right.
frequency spacing is in between the uplink and downlink frequency.
Very right. So if you see this frequency N1, N2, N3 and all, you have some chunk of frequency in, see this, uplink side. This is your uplink and this is your downlink frequency. And of course, there will be some gap in between. So uplink and downlink frequencies are separate. That means separate transmission for uplink, separate transmission for downlink, separate band or frequency band for downlink. Now the bands here are TDD. That is your N34, N38, N39. These all bands are already defined as FDD, and these were also available for 4G. So what is TDD?
Time division duplex.
Sir,
Okay.
operation on time frames. Operation on time frames.
Look at the frequency here.
Sir,
2010 to 2025. The same frequency band is for uplink and downlink both. So that means some time is given for uplink, some time is given for downlinks. That's why we call it time division duplexing. Again, some bands, that is N66, N70, N71, N74, these bands are again FDD, and these were also available for 4G. Right now, there is some new term N76 and N77, which is being called SDL. What is SDL?
Supplementary downlink, sir.
Right. In case of 5G, you can have additional spectrum in uplink and also downlink. If you have it in downlink, we call it supplementary downlink, right? Now let's look at these frequencies. N78, N79, right? And N70, 80. Up to here, let us see N79. These are TDD band. Just see. These are TDD band and these are new band. This was not there for 4G. This was not available for 4G. These are new band where N78 and N79 is there, and these are only TDD, defined as TDD. And now there are certain bands which are SUL. What is SUL?
Supplementary uplink, sir.
There are many bands for supplementary uplink. What can be the reason for having more number of supplementary uplink? Can somebody guess? Try
for
to answer
additional
this.
capacity, sir. For providing additional capacity for the band.
But why in uplink only? Why downlink very less, uplink many bands?
High requirement of upload data. Upload data may be very, very high because they are the source of that.
Okay, any more answer? So actually, if you look at the characteristic of coverage, so coverage because of the uplink, because your mobile, so your base station you can pump 40 watt power, 60 watt power, but from your mobile you can pump only 2 watt power, right? So with higher frequency, suppose a higher frequency transmission, millimeter wave or midband is going on. So in downlink direction, you may be covering a larger area, but in uplink direction, your coverage would be less. And because of the uplink, your overall coverage is less, right? So the concept, what concept 5G is trying to use, that for uplink, I may use a lower frequency band. Just see, these are all lower one, 800, 700, 1700. These all supplementary are in either low band or mid band, right? So the purpose is that to enhance the coverage, I'll be using additional lower side of the band for uplink, so that uplink and downlink both are available to the device and have a better coverage even using the mid-band frequency or millimeter wave frequency. Is it clear? Yes, no in chat box, please. Please write something in the chat box whether you understood. Yes or no?
Sir, how to achieve the optimal performance of the millimeter wave when you are using the lower band? That means if you are above going above 24 gigahertz.
Let me explain it again, because somebody, yes or no, there are two answers. So suppose there is a 3.5 gigahertz base station, right? So because of the BTS can have more power, more capability, more processing. So I can say cover 3 kilometer example. But since there has to be some uplink data also, in uplink direction, your devices may not be able to pump that much data. So that means for purpose of uplink, your coverage is only 1.5 kilometer, and downlink it is 3 kilometer. So practically your coverage is 1.5 kilometer. So how to enhance this coverage? So in case I also deploy second frequency in the lower side only for uplink, your device will have 2 transmitter, 2 receiver kind of, or 4 transmitter, 4 receiver. So in uplink direction, it can use the lower band, which has a higher coverage. In downlink direction, it can get more data on mid band. So in that way, I am able to increase the coverage. That is one of the kind of a use case. Is it clear now? Yes, no, please. If it is clear,
yes, sir.
Okay, thank you. And now finally the millimeter wave, the 3 bands which I shown you is here. These all are millimeter wave in TDD mode they have defined. Just see, 3GPP has defined these as TDD mode. So these are different bands. Now I want to come to one question before I move to the next slide about the problem of US, where because of 5G, some airline were not allowed to fly at that particular of time. Can some of you try to answer that or guess the answer?
See, I know that case, Ashokji, because I had dealt with that when it was reported in papers. First, it was reported from US, where they banned it. I mean, the flights, even Air India flights were banned. So in India, that problem is not there, but in US, that problem is there, because although the bands were decided and fixed, what will be for 5G and what will be for the airlines, because airlines use some frequencies which they send downwards, I mean, towards the earth, and they take that reflection, and then that is called altimeter. I mean, that frequency altimeter, that is basically to judge what is the height of the flight. So while landing, mainly it is used for maneuvering the flight and controlling the flight actually. So what happened in US, that what was their 5G bands were already prescribed, and this was slightly away only. So out of band emissions were there in the 5G, and with the out of band emissions, it was suspected that it would interfere with the flight altimeter. And if the flight altimeter is interfered, then the whole flight will be under jeopardy. It will be a big problem. So they had to ban it. Now that was same thing was referred in India. There was a lot of hue and cry. People referred to TRAI, and so many press conferences were held. And TRAI clarified that such problem is not there in India, because that out of band emission also is not near to that altimeter, and so that problem was resolved. So that's what I understand. Thank you.
Okay, anybody else want to answer it? Sir is very right. Any more supplement one can give? Yes, sir. PK Singh sir has also opened. Sir, please go ahead.
Yeah, thank you, Ashok. I think the radio altimeters, they basically use a frequency spectrum which is centered at 4.3 gigahertz. And the bands which we are making use, although it has been indicated that the band doesn't extend to that center frequency, but the frequency spectrum of the radio altimeter gets covered in the 4.2 to gigahertz band, and that was the reason why the 5G frequencies were impacting the radio altimeter being deployed in the normal aeroplanes. So that was probably the reason, and studies is being contemplated in India also, whether this problem really exists for the Indian scenario or not, because we have defined the bands which is available on the screen as 3.3 to 3.8 and up to 4.2 and 4.4 to 5.0 gigahertz, and then the 24 onwards to 40 gigahertz. These are the different bands. That center frequency is not getting covered with our bands, but still study is required. And that is what is the current status as far as India is concerned. Thank you.
Thank you, sir. Thank you, sir. So, so I will, for the benefit of all other participants, so Jha sir and PK Singh sir have answered rightly. So let me tell you that the aircraft system, they use altimeter. The system is called, that device is called altimeter. Jha sir has explained what it is. So it uses frequency between 4.2 gigahertz to 4.4 gigahertz. As sir said, 4.3 is the center frequency. So where it is, just see, although these are not being used in 5G, just see this part, whatever falls here is between 4.2 to 4.4. So your altimeter traditionally is working here, right? So in USA, they have actually allocated this N77 to their operators and even N79. And the problem is like the aircraft, many aircraft are kind of an older aircraft, and the altimeter system which they are having, they have out of band transmission, or you can say that the filter which they have is not very precise. So they will get lot of interference from nearby 5G sites, because and also whatever they transmit would affect the 5G network. So this may create problem while landing a aircraft or take off a aircraft which uses the altimeter kind of equipment. So that was the issue in US. So how they solved it today, because now aircrafts are going on. So what they have done is, first thing, what they have created some kind of buffer zone. That's a short-term solution, buffer zone near airline where the 5G operators will not deploy N77 or N79 frequency band. That buffer zone they have. So that's a kind of a short-term solution they have brought in. Parallelly, they are working on that all the aircraft should have the latest altimeter equipment, transmitter and receivers with a good and precise filters, so that it doesn't impact, doesn't have impact from N77 and N79. So that is what sir explained. In India, we are not using N77, but we are using N78, which is again very, very far away. So N78 band will be actually auctioned as part of mid band. So as such in India, this problem is not expected. Now let us talk about Japan. Japan is also using N77 and N79. They also have airport, aircraft, etc. This problem was not reported from Japan, all because their aircraft, they have already have very, very good altimeter with precise filter and all. And as sir had said that in India also, although since this issue has cropped in, some study is going on, but in a broad sense, this problem will not be there in India. So any supplementary question, or shall I proceed?
No supplementary question, Ashok. Only that Boeing was affected. I mean the Boeing operations whether they were from US or India, from another
No, no,
place.
no, not it was not Boeing, sir. It was any aircraft going to US at that point of time was affected. It was not specific to Boeing, sir. Because
So,
India Boeing flight was stopped, so that became a highlight.
Yeah, we knew more about Boeing because a lot
All
of human was there.
that came into newspaper, so that became highlight.
Thank you.
But now let us look at the channel bandwidth supported in 5G. What kind of channel bandwidth is supported in 5G? So before we discuss 5G, let us talk about channel bandwidth in our earlier technology, 1G, 2G, 3G, and 4G. And I'll ask this question from you all, that if you have heard about 1G, what kind of channel bandwidth we had? Any guess? In chat box or you can open your mic.
30 kilohertz.
30 kilohertz, very right, sir. 30 kilohertz was channel bandwidth. And what was that in 2G? How much channel bandwidth we had in 2G?
200 kilohertz.
Yeah, 200 kilohertz. And in 200 kilohertz, we used to have 8 time slots, right? So 8 customer can actually hang on this 200 kilohertz channel. Now in 3G, what was the channel bandwidth?
5 megahertz.
5 megahertz. So from 200 kilohertz, it become a 5 megahertz. But in 2G,
Sir, your voice is not coming.
some operator will have 10, some operator may have more, depending upon the customer base at that point of time used to consider. And in 4G, what is the channel bandwidth supported? Anyone? Any guess? Karan?
So 20 megahertz, and but with carrier aggregation 100 megahertz.
Very right. 20 megahertz. Sorry. 20 megahertz. And of course, it has carrier aggregation up to 5 carrier aggregation. So it would have gone to 100 megahertz. Now let us talk about channel bandwidth in 5G. Let me erase this thing. In 5G, we had talked about FR1 and FR2. FR1 are the frequencies from 410 megahertz to 7.125 gigahertz. That is low and mid-band frequency. So here the maximum channel bandwidth supported is 100 megahertz without carrier aggregation. Carrier aggregation we'll talk later. So even if you compare with 4G, where we had only 20 megahertz max 1, so it's a 5-time increase in the FR1 itself. Although 5G will support 5 megahertz, 10 megahertz, 15 megahertz, and so on. Just see these figures. So 5G can support all the channel bandwidth, which is shown here. 5, 10, 15, 20, 50. Maximum is 100 in FR1. In FR2 frequency range are from 24 gigahertz to 52 gigahertz up to release 16. Release 17, they have taken some more. 15 and 16, these were defined. So the maximum here is 400 megahertz. So that's why we say the maximum channel bandwidth supported in 5G is 400 megahertz. But of course, that is in FR2. FR1, it is only 100 megahertz. There are certain other parameters which I'll talk about in subsequent classes. Any question on this slide? Okay, if no more question, then I'll proceed. So the next aspect is what kind of waveform and modulation is used in 5G new radio. So before we talk about these modulations, etc., let us talk about 2G, 3G, 4G, and then come to 5G. So 2G, 3G, and 4G. So 2G, what kind of modulation we were using, or what kind of multiplexing we are using? 2G में what you used to do that whatever bandwidth is given to you, you used to divide into 200 kilohertz chunk. So that becomes frequency division multiplexing, and you had 8 slots, so you are using time division multiplexing. Am I right? In 3G, you have a single 5 megahertz, right? So that we used to have code division, TDMA, code division multiplexing or multiple access. And 4G, can someone guess what is the waveform used in 4G?
OFDM. OFDM.
Orthogonal frequency division multiplexing and multiple access, both. Okay, now in 5G, the same orthogonal frequency division is used. Let me erase the ink. Okay, so we use orthogonal frequency division multiplexing in 5G also. Why we call it orthogonal? Can somebody tell me? Why we call it orthogonal? Any answer from any one of you?
90-degree phase shift, sir.
Two adjacent carriers are 90-degree.
Okay. Any more answer?
In this, we are using the parameters.
Are equal in number. 0 and 1 are equal in number.
Okay.
We are using the parameters which are orthogonal. I mean, so many we can bring in this, and they are all independent of each other in the planes. So that only orthogonal things can give this independence.
Right. So basically, orthogonal here means, so these are 4 subcarriers you see here. 1, 2, 3, 4. So when there is a peak of this subcarrier, at that point of time, there is null for all other subcarriers. So that means other subcarriers will not interfere, and that's why we call it orthogonal. So what we do, so let me give you one example. That suppose theoretical, very theoretical, I have 5 megahertz of channel bandwidth. And in orthogonal frequency division multiplexing, what we do, we use a smaller size subcarrier. That means the distance between, in terms of frequency, between the 2 subcarriers, say it is 15 kilohertz. 5G, I'll tell you how much it is. 15 is also there. So 15 kilohertz. So how many subcarrier I can have? 5 megahertz divided by 15 kilohertz. Can somebody tell me how many subcarrier I'll get? Just calculate on your calculator. You can do 5,000 by 15.
334.
Pardon?
334.
3,300.
334. So that means I'll have 334 subcarriers, and on every subcarriers, independent data can be modulated. So that means the serial data you convert into parallel 334 data and transmit simultaneously using this orthogonal frequency division multiplexing. So that way you are able to transmit more data without, I mean, so it has got very, very efficient way of transmitting data in this particular concept. Let me erase and move further. Okay, now let us talk about various modulations. One is the waveform, other is the modulation. So, so the modulation used in 5G up to release 16 is UPSK, 16 QAM, 64 QAM, and 256 QAM. So let me ask, when I use QPSK, how much data I can transmit on one subcarrier, and in a particular time, we call it symbol time. Can somebody tell me? In one symbol time, let us assume this as a 1 millisecond. In 1 millisecond, on one subcarrier of 15 kilohertz, how many bit I can transmit if I'm using QPSK?
2 bits.
So answer is 2 bit. You are right. So you can transmit 2 bit per second per subcarrier. Right? Now suppose you have 16 QAM modulation. So how many bits you can transmit?
4 bits.
So you can double the bit, 4 bit per second per subcarrier you can transmit. So you have doubled the speed and so on if you can calculate, right? So if you go on higher order of modulation, you are getting capability of transmitting more data on the same radio resource, right? But the problem is that if you use higher order of modulation, you require very good signal to demodulate. So your coverage reduces. So what system does that the users who are near to base station will get better speed compared to user who are on the edge of the network. So depending upon where a device or a user is, what is the signal condition, the order of modulation is decided mutually between the device and the base station. Some comparison between a frequency division multiplexing and OFDM. In case of frequency division multiplexing, all of you would be knowing that we divide frequency into chunk of small frequency bands. We also keep some guard band in between. And then we kind of modulate these and transmit the data after multiplexing. In case of OFDMA, these guard bands are not required because of the orthogonal frequencies. So it doesn't need guard band and there are certain other efficiency which we get. Now let us calculate. I would request all of you to do this calculation. Please open your calculator. I am giving you these 3 parameters. I have a 50 megahertz channel bandwidth. 50 megahertz channel bandwidth. I have to reduce this guard band from both sides. From this side, 692.5 kilohertz, and from this side also 692.5 kilohertz. And whatever comes here is called transmission bandwidth. And now you have to calculate how many subcarriers I can get if the subcarrier spacing is 15 kilohertz. So whatever TX bandwidth you get, divide by 15 kilohertz, and you will get number of subcarriers. I request all of you to calculate and tell me number of subcarriers. Yes, Himanshu, your formula is right. I request all others to calculate this. Karan is also right. Please calculate and yourself and write in chat box.
48.617, sir.
That is transmission bandwidth. Now divide by 15 kilohertz. Okay, 3241 is the right answer, which Karan and Sudhanshu and Himanshu has given. Rest, I don't know whether you are able to understand, but these are simple things. Please calculate so that you understand better. So transmission bandwidth 48.617 is right. And number of subcarrier 3241 is also right. So as we know that 5G supports even 50 megahertz, and these were the guard bands. So it will have 3241 subcarriers. And now you can calculate how much data it can carry. Suppose very theoretical and rough. Suppose I have 256 QAM modulation. So how many bit I can do per subcarrier per second? 7 bit? 8, because 2 to the power 7 is equal to 256. 7 or 8?
8, sir.
8.
8, right. So I'll have 8 bit. I can do on the every subcarrier, say per second. So how much it will come? 3241 into 8 bit per second. right? Is there anything else I'm missing? Every second I can transmit only this much bit if I have only 50 megahertz. I'm not talking about other aspects, so I'm just talking about very plain. So this kind of speed you can achieve with 50 megahertz with 3241 carrier and with 256 QAM kind of a modulation. Very rough calculation. There are many other parameters which I'm not considering as of now, just to make you understand. Now let us understand that QAM thing. So let me ask you, let us first recap the modulation. So what is amplitude modulation? Someone from you? Jha, sir?
Yeah, Ashok, actually, I had one small doubt in the previous calculation. As per my calculation, it was coming out to be 3051 instead of 3241. Because what I did that in the guard band is on both sides, that is 692.5 is on both sides. Okay.
Yes.
So actually the frequencies, the gap between the two frequencies would be double of this. I mean, from both sides you are expecting. So I took that 1385 kilohertz actually. I mean,
no. So I mean, not 13. You have to reduce that from the channel bandwidth, not from the subcarrier spacing.
No, subcarrier spacing I am keeping same. Let us say that
spacing you cannot change because of, I mean, that is a requirement. The channel bandwidth, overall channel bandwidth which you have from both sides, you are not reducing that from every subcarrier, sir, because it is orthogonal. It is, I mean, there is no guard band here between the subcarrier. Guard band at the end only, and the start.
Right. So that was my mistake. I got the point. So basically, it is not from all subcarriers, correct?
Yes.
So
that is the
advantage. It is only for the entire band only, once only. I mean, both sides double.
Right.
Okay. Thank you.
Okay. So can somebody tell
one
me?
more doubt, sir?
Yeah, please go ahead.
Sir, 3241 multiplied by 8 you mentioned. So one subcarrier of 15 kilohertz, you said it will carry only 8 bits.
In a second. I'm just taking some.
Right. 8 bit per second, right? So that way it's only around 2.5 kbps. Sorry, 2.5 yes kbps. 24 kbps. 24 kbps is the speed, right?
But what I told you, just a rough one. There are many other aspects which will increase the speed. We'll talk about that. So I was just giving you an idea.
I mean, even roughly speaking, 50 megahertz channel bandwidth, a throughput of only 24 kbps seems very low. So what I'm trying to doubt is actually like when you say subcarrier, one subcarrier of 15 kilohertz can carry only 8 kbps. This is where I'm doubting.
So other aspect I'll tell you. I just said in 1 millisecond, whereas I'll tell you.
I think we have to. I feel we have to multiply by 256 also because we are using 256 plan.
I'll just tell you. Since you have raised this question, in 1 millisecond, I'm talking about 4G. In 1 millisecond, there are 7 symbols. I'm talking about 4G now. There are 7 symbols, right? In 1 millisecond, there are 7 symbols. Means whatever your answer you got, actually you have to multiply it by 7 if you're using 4G LTE, right? In case of 5G, it is 14 symbols, right? So you have to multiply again by 14. Not only that, in 5G, what you have, this time slot which I talk about 1 millisecond, you also have half millisecond, 1/4 millisecond. In every such time slots, you have 14 symbols. So you will achieve the rate which 5G has envisioned. I gave this calculation to you just to understand. For the
okay, I understand. I think the confusion is when you say 8 bits per second, it's not per second, it's per millisecond actually, right?
Yes.
It is 8 bit per millisecond, not second. Okay, so I understood wrongly.
Not only millisecond. Within the millisecond, there will be 7 symbol in case of 4G, 14 symbol in case of 5G. Not only that.
I got the point, sir. I got the point.
Not the point. I just gave you calculation that how to calculate the data. Right? I said there are many other parameters which we'll talk about.
Sure.
Okay, so
yes, sir. Yes, fine.
to make you understand the concept, I told you that assume 1 millisecond or 1 second. Okay, so can somebody tell me about amplitude, frequency, and phase modulation? Just very quickly.
Sir, in amplitude modulation, the amplitude of the carrier gets changed due to according to the instantaneous amplitude of the modulating signal.
Very right. And frequency?
And in frequency modulation, the frequency of the carrier changes according to the instantaneous amplitude of the modulating signal.
Very nice. And phase?
And in phase modulation, the phase difference of the this carrier gets changed as per the instantaneous amplitude of the modulating signal.
Very nice. And what is the combination of amplitude and phase? You change phase also and also the amplitude. So the QAM modulation is nothing but using the phases, I mean different phases. So for example, if we are talking about QPSK, there are 4 sets of phase and amplitude. 1, 2, 3, 4. There are 4 states. For example, यहाँ पे ये phase है जो भी डिग्री है 45 डिग्री, यहाँ पे आपका 90 डिग्री आ गया 270 and so on. So basically you are changing the phase. So you have 4 states. So that means you can transmit on a one subcarriers 2 bit of data. 2 bit can represent 4 numbers, no, 0, 0, 0, 1, 1, 1 and 1, 0. So if you have QPSK, which is also called 4 QAM, you can transmit 2 bit of data on a subcarrier for a symbol duration. So it's, I'm not talking about 1 millisecond, half millisecond. I'm saying symbol duration because symbol duration will vary based on various aspects, which we'll talk about. If you have 16 QAM, that means there are 16 states. And I mean, phase and modulation combination, there are 16 states. 4 here, 4 here. So you can transmit 16 kind of different data on this. That means you have 4 bit because 2 to the power 4 is equal to 16, and you can have 16 such states, right? 4 bits means 0, 0 से लेके FF तक ये जाएगा hexa में. So 16 type of information you can transmit. So number of bit you are able to transmit within the same symbol duration has doubled and so on. Now, if you recall my initial slide, which I said that 5G uses just here 16 QAM, 64 QAM and 256 QAM and QPSK. That means I'm saying that 5G uses this one, 64 and 256. ये वाला नहीं यूज करते, ये वाला नहीं यूज करते. What is the reason we are not using this 32 QAM and 128 QAM? Any guess from any of you? Why we are not using 32 QAM?
Odd number of symbols, sir.
Please again, come again, sir.
Odd number of symbols, odd bits.
Odd number of symbols. So इससे क्या गड़बड़ होगा?
Overlapping हो सकता है, sir.
Overlapping हो सकता है. Rajesh Rai ji has raised hand. Do you have any question, Rajesh ji?
सॉरी मैं पहले पूछ चुका हूं सर, इसलिए वो शायद ऑफ करना रह गया था. तो इट इज ओके सर. रिप्लाई टू दिस कुड बी पॉसिबली बिकॉज वी हैव normally 8 bits and so we have 4 bits combination. So the moment you go for 7 or 5, then it will be a waste of either a waste or maybe a shortage of some bit. So probably that's why we have to go in a multiple of 4 actually.
Sir, the constellation is not like square shape in this 32 QAM and 128 QAM. The constellation is not square shape.
Yeah. So basically, if I have to give a very broad answer, so suppose this is BTS and here is the user. if I am able to receive a signal which is modulated with 32 QAM, I'll be able to actually receive even the 64 QAM the way it is modulated. So there is no, benefit in using 32 QAM when I can actually receive 64 QAM at the same place at the same signal quality. So that's why we use these 64 and 256 and not this 32 and 128, because although we can use technically, but it's of no use. No benefit. I'll just take one call and hello. So may I call you later? I'm in a meeting. Okay.
Ashokji, I have just one question on that.
Haji, sir.
Just now you have said that with 32 QAM and in 64 QAM, the same logic can be extended to the 256 QAM also. And why we will use 64 QAM? Why not we will use 256 QAM only?
नहीं आप ये देखिए सर, यहाँ पे आपको फिगर देखने से पता चलेगा कि so the practically what has been found that for say for 128, so whatever signal level required to receive a 128 more or less same is equal with 256 QAM, sir, and that is not the case with 64 and 256. That is not the case with 64 and 256. It is between 128 and 256 and 32 and 64. This is how is explained in various textbooks, sir. Okay. Thank you, sir. So in OFDM, the very broad and basic modulation, I'll not go much into detail, that as you know that the serial data is getting converted into parallel data because I have n number of subcarriers and data is modulated on those carriers. So we call it constellation. When we convert into this QAM, a constellation is made. So we map that QAM source onto the n orthogonal subcarriers. And after that, what we do is we do IFFT, inverse of fast Fourier transform. So basically what we are doing is we are combining all those subcarriers into a single type of carrier, summation of all n subcarriers onto the transmit side, and we do reverse onto the receiver side. So that is a basic diagram. I will share with you a detailed reading document on OFDM. It's a very big concept which you can go through in case you are interested. I'll give you a link where this is explained in a very beautiful way. For our class, let's move forward. So I think it's already 5. So let me stop here and I'll continue this session maybe tomorrow. Tomorrow, and then let us discuss if anything you want to discuss, and then close it for today and continue tomorrow. So any query or question today, or shall we kind of break for today's? Thank you, Praveen. Yes, sir.
Sanjay Kumar from Ranchi.
Sir, आप वीडियो खोलें सर.
Okay.
Right, sir. Yes, sir.
First slide था ना, तो जो उसमें दिखाए थे कि you had told that there are some 205 plus commercially yes commercial networks in all across the globe. Now I have a small query. How many standalone networks are commercially launched?
Sir, standalone as of today only 30-35 operators have done it, sir. So this was 30-35 and rest are all NSA as of now.
30-35 commercial SA networks.
Commercial SA networks are already live, and this was confirmed by one of guy from Geo also today. We had that webinar in the morning, sir. Geo session, he himself told about 35, and that is also a figure. If you go to the GSA website, sir, they are tracking.
GSA.com.
GSA com.com.
Yeah,
So they
yeah.
are also getting a lot of data. So they also, in some of their report, they have talked about this, sir.
Thank you.
Thank you, sir. Any more question from anyone?
No question, Ashok, but just I want to say you are working very hard on this, so that's great to see.
Thank you, sir.
Yes, it
Thank
takes a
you
lot
for
of
this.
effort to explain. So great.
Since it is my third course, sir, so it has become easier a bit. First and second was tough because everything was new. So when I was preparing for certain topic based on release 15, release 16 came by 3GPP, so I had to read it again and include. So very dynamic. So now release 17 has come. Some aspect I have to include on this. Maybe going forward during other sessions, I'll try to give you some distinct aspect of release 17 and 18 also, sir.
Yeah, and WRC is also going to happen again. So
yeah,
after 19, so that is another. Yes.
Yes. Yeah. So if there is no more questions, let us close for today. So thank you so much, and let me inform you that while I was taking session, although it is recorded on the Teams platform, in addition, I have also made it live on a YouTube channel, which I had given link on your WhatsApp group. So in case suppose you are some outside and not able to access Team, so you can at least go through my session on the YouTube channel itself, which I have given you the link. That was going live stream from my second PC. So you can also go through that. Thank you so much.
Sir, just wanted to check. In fact, those who are not registered for this and they are interested, can I share the link and they may join as a guest?
For them, you share the YouTube link. They can go at any point of time. So whatever session I'll be taking, that will also be available on YouTube, available to everyone. The expert speaker from private sector, we cannot make them public because of their proprietary nature of item they may have.
Okay. Okay, sir. Thank you.
Thank you.
Thank you, sir.
Thank you so much.